About the fault current limiters or fault current limiting. So here in the first figure, if you see the design, in this design under normal operation, both the thyristors, that is thyristor pair, here it is. So both the thyristor will be off, okay, when it is normal condition. For normal operation, both thyristors will be off, okay, and current flows through the L1 and C. Current flow to the L1 C, and here the impedance of L1 C is selected such that at 50/60 Hertz, that is omega L1 minus 1 divided by omega C equals to 0. Okay, so the impedance of L1 and C is selected, that is omega L1 minus 1 divided by omega C equals to 0. This introduces a zero impedance in series with the line. This introduces zero impedance, okay, zero impedance. This introduces zero impedance in series with the line. When there is a, this is during normal operation, okay, this is during normal operation. So when there is a fault, both thyristors go into the full conduction, okay. So when it is a fault occurs, okay, during a fault, both thyristors will conduct. So in that case, L2 here L2 is connected, okay, L2 is connected in parallel with the C. During normal operation it will go like this, it will go, okay, it is not at all related, okay. So during the fault condition, so it will be connected with parallel. Capacitor is connected with the L2 is connected in parallel with C, thus and increasing the total inductive impedance in series with the line. So now it will increase the inductive impedance in series with the line. So inductive impedance or you can write like this ZL, so that you can remember inductive impedance increases in series with the line. So here varistor, you can observe here varistor snubber circuit is used. So here varistor is used to limit the transient voltage across the thyristors, okay. Varistor is used to limit the transient voltage across the thyristors. If the more excess voltage, that is the rate of rise of transient voltage, then that is limited by the snubber circuit, okay. So if any variations voltage or transient voltage, that will be limited by the varistor. If any the rate of rise of transient voltage, then that will be limited by the snubber circuit. This is about the figure 1, okay. Next in figure 2, okay, that is GTO pair. Here they have used thyristor, here GTO, gate turn off thyristors. So here they have placed in a series with the line. So here when a fault is detected, so in case fault is detected, the normally conducting GTO switched off and the current is diverted to the parallel reactance. So during the normal condition it will flow like this. During the fault condition, okay, during the fault condition what happens, so it will be diverted, okay. So this will not, the current will not pass here, it will be diverted to the current limiting reactance which is connected parallel, okay. So the current is diverted to the parallel reactance. This limits the fault current. In this circuit, it is proposed for both current limiting and also for the interruption purpose. Okay, it is possible to continuously switch on and switch off the GTO switches so that fault current is shared between the GTO and parallel limiting reactance. Okay, this is about the figure 2. Here you remember during a fault condition it is diverted. Okay, during a fault condition it is diverted and it is gone through the current limiting reactance. Okay, next in the third figure they have used IGBT switch. Okay, here in this design normal operation the bypass switch takes the current. During the normal operation the bypass switch will take the current, that means it will be closed. Okay, so whenever there is a fault the bypass switch will be opened. So for normal operation bypass switch will be closed. Okay, for normal operation when there is a fault condition the bypass switch will be opened. The bypass switch will be opened, and here the bypass switch will be open and IGBT will take over the current flow. Okay, here the IGBT will take over the current flow. The IGBT are switched off when the fault current reaches a preset value. So IGBT take over during fault if it is more than preset value, then it will be off. IGBT are switched off when the fault current reaches a preset value. When the fault current reaches a preset value, then the fault current flows through the varistor. So the clamping voltage of the varistor is set to be higher than the peak supply voltage. Clamping voltage of varistor is set to be higher than the peak supply voltage. Okay, peak supply voltage. Therefore the fault current starts decreasing. So when the current reaches a minimum value, if the current is decreasing, then automatically the IGBT is turned on again. In this way the fault current is maintained below a maximum value. So once the current starts decreasing, the IGBT will, before it was turned off, now when it come to the preset value, when it come to the normal value, as it decreases, then it will be IGBT will be switched on.